Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform where you get the opportunity to learn from India's best and top educators and prepare for your aspired competitive examination. So just let me check the thing. Good evening, Indrajit. So I welcome you all to this session and you know about me. Still, it's a brief introduction about myself. My name is Vidyapati Kumar and so good evening, Asis. Good evening. So this is my brief introduction. My name is Vidyapati Kumar and I have a 4 plus year of teaching as well as research and development experience. I have done ME from Jadavpur University and I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of several research papers. So this is the fourth part of analysis of metal cutting, and in this session we are going to do a lot of PYQs, and this is the end of analysis of metal cutting. This session is going to be the end of analysis of metal cutting, and on the next classes we are going to see the tools, tool fracture, how the tool wear are there, and machining parameters. We are going to analyze those. So you can download the Unacademy learning app, because the Unacademy learning app, I'm teaching you the strength of material. I'm teaching you the strength of material at 11 a.m. So you can download the Unacademy Learning app, where I'm going to finish the strength of material at the same platform as well as manufacturing in the YouTube. And there are the benefits of the Unacademy Learning app, that daily live classes, you will be getting the daily live classes. Structured courses are there, that the courses are in various structured and in chronological orders. Tests and quizzes, you can give a lot of tests and quizzes, as well as unlimited access of the material is there. And if you are going for a plus subscription, then the benefit of the plus subscription is you will get daily live classes, complete coverage of subject, complete coverage of subject. So this is the benefit, that your all the subjects is going to be covered with so much of precision. Live test and quizzes you can give. You can see the courses are in structured, and there are a lot of educators, you can study from anyone. As well as, once you enroll for a plus subscription, you get opportunity to set your personal coach, and that personal coach will help you throughout the preparation of GATE and ESE. So the benefit is that only one subscription would give you the benefit of GATE as well as ESE. So only one subscription you have to do, and you will get the benefit of both the examination of GATE and ESE. So for a 12 month it would cost around 25,000, but if you would use my code SIRVK, then the discounted amount would be 22,500. Similarly, for a 24 months it would cost around 30,000, but sir, if you would apply my code, that is SIRVK, then the discounted amount would be 27,000. So if those who are in second and third year, they should invest in this, because that cost around 37 rupees per day, and this much of investment is quite justifiable. So if you are planning to purchase the plus subscription, please do use the SIRVK code, and I will provide my personal mentorship as well as personal attention to you guys for the entire GATE and ESE preparation. Okay, so in today's lecture, I will start with one topic which I have forgot to mention. Right, that topic has been overlooked by me. So today I am going to just deal that topic. Okay. The topic is the effect of nose radius on surface roughness. Okay, so this is the topic that I am going to discuss. If you my audio, video, everything is clear to you. Okay, fine. See, so this is the one topic that I have actually overlooked, and this topic uh, comes with the one questions, okay, in every gate examination. So you just have to prepare for that. So what is the effect of nose radius on surface roughness? So see, we have discussed that if we increase the nose radius, how the surface roughness is going to be affected, right? So see, this is your this is your peak and valleys. Okay, when you machine a surface, you will get something like that. Okay, and this height, this height, okay, is h max. Okay, h max. So h max is given by f square by 8r. Okay, where f is feed rate, r is nose radius. Okay, next point is there that this h max is, this h is also defined as f, that is feed by tan of cs plus cot of ce, where, so this is the one equation, another, clear? Now where cs is what? Cs is side cutting edge, and this ce, the ce is end cutting edge angle, end cutting edge. Fine. So this is the two equations that is important from nose radius point of view, and the relation between surface roughness and the nose radius. Okay, so you just remember these two equations. I have already explained you what is the behavior when the nose radius is increased. It is when it is sharp, then how the surface roughness looks like. So I have already discussed these things. Only this thing has been overlooked. So kindly note this formula, and this formula is very much important. And just take a screenshot of the note down this formula, and I am explaining one questions related to this. Yeah. So now see, there is one question. I hope you have noted down everything. So just see, there is one question. This question is of GATE 2005. Okay, and the question is that in tool signature, and the tool signature is for P, it is 5566830, 0. Okay, so this is an ASA system. Okay, and for another that is of a Q, it is 5 5 7 7 8 15 0, and this is in any other system. Okay, this is also in ASA system. So if HP and HQ denotes the peak to valley height, then ratio of HP by HQ is, okay. So you just need to find this. So just now I have told you the expression of this height. Okay, try to solve it. Yes, good evening, Nishant. Please try to solve this. We have introduced one uh, new concept is there of relation between nose radius and surface roughness. So this is the one relation that you should remember. Okay, this is the one relation. This is the one relation, and this is another relation that you should remember, which is between the feed nose radius, side cutting edge angle, and end cutting edge angle. Okay, please try to solve this question. Please tell me the answer. This is the basic question. If you could remember, okay, Asis has given as 0.56. Let me check it, Asis. No, no, Asis. No, Asis, kindly check your answer once again. It is not 0.56. Okay. Please check your answer. See, what I have told you when I was giving you the nomenclature, how the nomenclature looks like. So this would be your rake, fine. This would be your rake. This would be your clearance, that is relief angle, rake. This is going to be your relief, and this thing is going to be your cutting edge. I have already explained this concept. How you people are getting these weird answers? Yes, Asis, now it's correct. Now it's correct. See, so cutting edge is what? This is the cutting edge, right? Now see, I have already told you how to remember this thing. Rake, this is alpha B, this is alpha S, this is gamma E, this is gamma S, this is end cutting edge angle, and this is side cutting edge angle. Fine. That is, remember the thing. I've told you how to remember that ESE engineering services examinations, right? So in this way, I have already told you how to remember those things. So if you have any problem, then please check that video. Feel free to check that video. So this is the CE for tool P and CS for tool P. Fine. So if I would write the HP, HP would be what? F by tan CE plus cot CS. Okay. Now what is CE for P? CE is going to be your, okay, sorry, that is tan CS unit. So this is going to be your CS, this is going to be your CE. Fine. Now what is the CS for P? CS for P is 30. So tan of 30 plus cot of 8. Fine. So this is for a HP. So let it be equation 1. For HQ, what should be the relation? F by tan of CS plus cot of CE, and this would be F by CS would be what? This is going to be your CS. So tan of 15 plus cot of 8, because this is going to be your CE. Let this be equation 1. So HP by HQ is going to be equal to F by tan of 30 plus cot of 8 into tan of 15 plus cot of 8 divided by F. The relation would comes to be HP by HQ is equal to tan of 15 plus cot of 8 divided by tan of 30 plus cot of. Clear? Clear? And if you would calculate this, then you would get the relation. Okay, then you would get the relation as 0.9597. Okay, clear? So this concept is clear to you? So is this concept clear to you? Is this concept clear to you? Fine. So there is only one thing is there. You have to remember effect of nose radius on surface roughness, how it is denoted in terms of angles, that is in terms of side cutting as angle, in terms of cutting end cutting as angle, and in terms of feed and nose. So I hope you have understood these things. Okay. 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 Great. Now please try to solve this question. Please try to solve this question. Okay, 2007 question is there. Please try to solve this question. Please try to solve this question. After 1 minute I will solve it, because this is the basic question. You should be able to give the answers because I have already explained the concepts to you. What happened? Please tell me the answer. Okay. See, in this question it is mentioned in orthogonal turning of low carbon steel. So whenever there is a orthogonal machining, so it simply means that lambda is going to be equal to 90. Clear? Now, uh, see, of a low carbon steel bar whose diameter is given as 150 mm with uncoated carbide tool, cutting velocity is given as 90 meter per minute. So cutting velocity is, this is the cutting velocity is given. Feed is given as 0.24. Okay, feed is given as 0.24. Depth of cut is given as 2 mm. The chip thickness obtained is 0.48. Okay, 0.48. The orthogonal rake angle is 0. So this is the most important thing. Orthogonal rake angle is 0 and principal cutting edge angle is 90 degrees. So this is 90 degree I have written. So they have told to find the shear angle. Okay, yes, as is correct. B answer is there. So basic question is there, alpha is given as 0, lambda is equal to 90 degree, and see, since it is orthogonal machining, so I have told you T, okay, T is equal to F sine lambda. T is equal to F sine lambda. Okay, so if T is equal to F sine lambda, then T is going to be equal to F, which is, what is that? 0.24. So this is your uncut chip thickness. Fine. Now chip thickness is what? Chip thickness is 0.48. Chip thickness is 0.48. Clear? So uncut chip thickness is given. Chip thickness is given. Orthogonal rake angle is 0. Then you have to find shear angle. So what you will do? Tan phi is equal to r cos alpha by 1 minus of r sine. Fine. How you can find the r? R is going to be equal to T by Tc. What is T? T is 0.24 and Tc is 0.48. Okay. So this is R. Plug in the values. Now tell me the answer. Okay. So answer is, this is going to be your point 0.5, and when you will plug in these things, so see, R cos of 0 by 1 minus of R sine of 0, which will be left as only R. Fine, because cos 0 is 1 and R sine 0 is 0. So you will be left at phi is nothing but tan inverse of R, which is tan inverse of int. So phi would be your 26.56565. This is what we have got. Okay, and answer is going to be your B. Okay, now see, please try to solve this question. Please try to solve this question. An orthogonal turning operation is carried out under the following conditions. A rake angle is given as 5 degree. Okay, so rake angle is given as 5 degree. Spindle rotation speed is 400 rpm. So spindle rotation speed is given as 400 rpm. Axial feed. Now see, what is the axial feed? Axial feed is given as 0.4 mm, 0.4 meter per minute. Okay, so just remember axial feed is given. Okay, axial feed is 0.4 meter per, and radial depth of cut is 5. Chip thickness is 3 mm. the shear angle and turning process will be what. This is the thing that you have to find, what should be the shear angle. Okay, please try to find it. Please try to solve this question. 18.88. Shivam has given 18.88. Indrajit has told 7.63. Okay. So what is the new thing that you have seen in this question? Can anybody tell me? What is the new thing that you have observed in this question? Otherwise, it is a very routine question, but what is the new thing that you have seen in this question? Axial feed, yes. Axial feed you have seen the new in this question. Tell me the answer. All of you, please tell me the answer. See, so I have received the answers. So see here. In this question, what you need to see, spindle speed is given as 400 revolution per minute, and feed, axial feed is given as meter per minute. See, axial feed, this is velocity, right? This is velocity, meter per minute. Try to see the unit. Try to see the unit. This is in meter per minute. So this is the velocity, right? This is the velocity. But if you could closely observe the other questions, see, in this question the unit of feed was what? Mm per revolution. Per revolution. Although I have already told you what should be the unit of feed, or what is the unit of feed, or how you can convert those things, but your observation should be very much clear about it, right? So the feed value and the feed unit is per revolution, but in this question the feed unit is in meter per minute. So this is not the actual feed that they have given. So first thing that you have to do is to find the feed. So how you can find the feed? So this is the axial feed. So F axial divided by N, when you will do, this is 0.4 meter per minute by 400 revolution per minute, and this minute get cancelled, hence you are left out with 0.4 by 400 into 100 into 1000. If you will do, then you will get in per revolution. Okay, and if you will calculate these things, you will get only 1 mm. So from here, feed is 1 mm per revolution. Clear? This thing is clear to you? This thing is clear to you? Even if the question was routine question to find the shear angle, but here is a twist. Here is a twist. So always read the questions very cautiously. Always read the question very cautiously, because you might get a twist in your questions, just like a twist we see in a movie, right? So feed is, this feed is 1 mm per revolution. Now since it is orthogonal turning, so you can say that since it is orthogonal turning, hence E is equal to F is equal to 1. Fine. So this is the uncut chip thickness. Now what about the chip thickness? TC is 3 mm. Fine. So you can find the R, which is going to be equal to 1 by 3. Okay, that is 0.33. And the shear angle, so how you can find the shear angle? Tan phi is equal to R cos of alpha 1 minus of R of sin alpha, and phi is going to be equal to tan inverse of R 0.333 cos of alpha, that is 5 degree, by 1 minus of 0.33 sine of 5 degree. And if you will calculate, you will get the answer as 18.862. Okay. Have you got the concept? Asis has told, sir, I am unable to understand this problem. Still now you have the problem? Still now you have the problem, Asis? Let me know. I have explained the question. अभी भी प्रॉब्लम है आपको आशीष? बताएं, अपनी प्रॉब्लम बताएं. See, there is a twist in this question. There is nothing. Okay, so you have the problem. See, Asis. An orthogonal turning operation is carried out under the following conditions. So examiner has told that there is an orthogonal turning operation in which this orthogonal turning operation is carried out with these parameters to be, that machining conditions. What are the parameters, sir? Okay, so see, so what are the machining parameter? Rake angle is 5 degree, spindle rotation speed is 400 rpm, feed. See, in all the questions whatever you have solved, in all the questions you have given the feed as, see, in the previous question when the feed was there, the unit is mm per revolution, feed unit is mm per revolution. Okay, mm per revolution. But in this question the feed unit of feed is 0.4 meter per minute. Okay, so that is not a feed, so this is actually a velocity. So now, and radial depth of cut is given as 5 mm, chip thickness is given as 3 mm. You have to find the shear angle. So routine question is there. So difference is that this is the axial feed, this is the axial feed which is given as 0.4 meter per minute. So what we have to convert, we have to convert this meter per minute, this meter per minute to this meter per minute to mm per revolution. Okay, because this is the unit of feed, right? So how we can convert? We can convert by f of axial feed by n. So see, axial feed is 0.4 meter per minute, n is 400 revolution per minute, minute get cancelled, so you will be left out with 1 mm per revolution. Okay, so this is the value of feed. Okay, and rest is the routine thing. Since it is a orthogonal machining, so T is going to be equal to F is going to be equal to 1 mm. Now you know the uncut chip thickness, you know the chip thickness, you will be knowing the R value. Fine. And tan phi is equal to R cos alpha by 1 minus R sin alpha. This equation you all very, you know this equation very much. So phi is going to be equal to tan inverse of this everything, and the phi is getting to be 18.862 degree. Okay, okay, thank you. No problem. See, now try to solve this question. This is the another question, GATE 2015. Okay, try to solve this question. Try to solve this question. Same routine question is there, but just a little bit twists are there. So you must be, your eyes and your ears should be open. Okay, brain should also be open while solving the question. See, rake angle is given as 10 degree. Feed is given as 0.14 mm per revolution. See, can you see it? This 0.14 mm per revolution. So this is fine. Okay. If thickness of the chip produced is 0.8 mm, the value of shear angle and the shear strain. Please try to find the value of shear angle and shear strain. A. Asis Shyam has given the option as A. Okay. Routine question is there. Only one thing is there, shear strain. So this is the shear strain, that is cot phi plus tan phi minus alpha. Okay. So this is the value of shear strain, and how you can find the shear strain? You have to find the phi, that is shear angle, and shear angle will be tan of phi is equal to r cos of alpha 1 minus of r sine of alpha, where r is this. This is the chip thickness. This is the chip thickness, right? This is going to be your chip thickness, and feed is given as 0.14. So this will be your uncut chip thickness, right? So 0.14 by 0.28. Okay, so this is going to be your r cos of alpha. Alpha is 10. 1 minus of 0.14 by 0.28 sine 10, and when you will solve this, you will get the value of phi. Okay, you will get the value of phi. So the value of phi that you will get is 28 degree. Fine. So that is something around 28.334. Fine, 28.334. So from the first equation only, you can say that this is going to be your answer, and when you will plug in the values in this equation, you will get the shear strain value as well. Okay, so part of 28.334 plus tan of 28.334 minus of 10, because this is your thing. Just let me calculate it. And the answer is 2.185, which is approximately equal to 2.18. Fine. So I hope this is clear to you. So I hope these things are clear to you. Now please try to solve this question. GATE 2016 problem is there. Please try to solve this question. This session is going to be the end session of analysis of metal cutting, and from tomorrow onwards I will be teaching you the tool wears, machining, Taylor's tool life equations, these things, miscellaneous things are there. And after that your metal cutting is over. Okay, metal cutting is going to be your over. But in this manufacturing you should practice a lot, and that is the reason why I am giving you so much of questions, because if you will practice a lot of questions, then you can solve anything. Manufacturing really wants the lots of practice from you. Okay, please try to solve this question. Okay, so I have got answer 29.7. Okay, fine, this is correct. Sam Babu, its correct answer is 29.7. Yes. Same routine question is there. Orthogonal cutting operations is there. Okay, so I have got a lot of answers. 29.7. See, orthogonal cutting operation is there. Tool is material is high speed steel. Rake angle is 22 degree. So rake angle is 22 degree. Chip thickness is 0.8 mm. So chip thickness, that is TC, is equal to 0.8. Speed is 48 meter per minute. So speed is 48 meter per minute. Feed is 0.4 mm per revolution. See, 0.4 mm per revolution, right? So F is going to be equal to 0.4 mm per revolution. This is orthogonal machining shear angle. So what this is F, this is the same thing, that is going to be T1. Sorry, the same thing is going to be T, that is uncut chip thickness. So T is equal to zero point 0.4 mm. You know the uncut chip thickness, you know the chip thickness, you can find the R, and you know the alpha. Just plug in these values in this equation. Tan phi is equal to R cos alpha by 1 minus R sin alpha, and you will get the answer. And the phi value that you will get is around 29.7 degree. Fine. These questions are very easy questions, so I don't think there is no need to repeat these things. These are just for your practice. Now try to solve this question. Try to solve this question. Now try to solve this question. Try to solve this question. Hmm, that is B. Yes. if you're talking about the previous question, like this question. Okay, my video is actually, there is little bit lag. Okay, I can see. Okay, that's correct, that's correct. Please try to solve this question. Yes, Sam has given the correct answer. Point it. I'm giving you more 1 minute. Please try to solve it, and after that I'll be explaining the question. uh no, Mukta, kindly check your answers. Kiran has told the correct answer. Point it. Yes, correct answer is C. Indrajit, correct. C. Orthogonal turning of low carbon steel pipe with principal cutting edge angle 90 degree. What is principal cutting edge angle? That is lambda is equal to 9. Fine. Yes, option C is there, Asis. So lambda is 90 degree. Now next is what? The main cutting force is 1000 Newton, right? So main cutting force, that is Fc, is equal to 1000 Newton. Feed force is 800 Newton. Feed force is 800 Newton. Fine. Next is the shear angle is 25 degree. Shear angle is 25. Now shear angle is 25 degree. So orthogonal rake angle is 0. Orthogonal rake angle is 0. Okay. Now see this, since the feed force is given as 800 Newton, so in this case Ft will be equal to the feed force, right? That is the feed force, and hence it is both are equal to be 800 Newton. Okay, because lambda is 90 degree. So this is the Ft. Now this is the Fc. You have got the Fc. Employing the merchant's theory, ratio of friction force. Ratio of friction force is what? F. With the normal force acting upon the cutting tool, that is N, will be. So how you can find the relation? What should be the relation? See, F is what? F is equal to Fc sine of alpha plus Ft cos of alpha. Clear? Now N is what? N is nothing but Fc cos of alpha minus of Ft sine of. Just plug in the figures, that F is equal to Fc. Fc is 1000 into sine of alpha, that is 0, sine 0, right? So sine 0 is going to be 0. Okay, plus Ft is 800. 800 cos of 0. So from here you are getting F as 800. Clear? And N is going to be equal to Fc. Okay, N is going to be equal to Fc, so N is going to be equal to 1000. So from here you got the value of F, you got the value of N. So F by N, that is mu, is equal to 800 by 1000. Yes, clear? How you have got the value of 0.8? Okay. Okay, so I hope this problem is, you have understood this problem. Sir, special case we can apply. Yes, yeah, we can apply the special case. Special case we can apply. See, whatever the material, whatever the content I have given to you, if you could remember those things, then you can solve the problem very easily. But what happens, yeah, to solve one question, there are multiple ways to solve a single question. So you should be aware about all the steps, so that, and sometimes what happens that only if you do not recognize that special case, you cannot solve this problem, right? So you just have to be very much accustomed with everything, so that uh, you can solve this problem very easily, right? Now please try to solve this question. GATE 2003. Please try to solve this question. Please try to solve this question. No, no. Ashish, see what I have told you. Please see. Please, all of you see here. Ashish has told that sir feed force is equal to thrust force. No, Ashish, no. I have told you lambda is equal to 90 degree and hence both are same. See, this thrust force is nothing but feed feed force by sine lambda. This is the relation. This is the relation in a turning operation. You just remember this relation, that how you can convert this. Okay, so this is the relation that converts the things. Okay, but here since this is a orthogonal turning, since this is a orthogonal turning, since this is a orthogonal turning, and here lambda is equal to 90 degree, so I can say that that is the reason what I have written, that ft is equal to f feed is equal to 800 newton. Clear, Asis? Please solve this question. No, no, it should not be. Option is not B. Kindly check your answer. See, these are again the routine questions. I don't find there should be any problem with that. See, depth of cut rake angle is given as 10 degree and shear angle is given as 27.75. So first step is what? Step 1 is what? Tan phi is equal to r cos of alpha by 1 minus of r of. Clear? Firstly you find the value. Firstly you find the value of r. Tan phi 27.75 is equal to r cos of alpha, that is 10 1 minus of r sine of 10. From here find the value of r. From here find the value of r. And once you will get the value of r, from here, from that value of r, you can find the thickness of chip. Okay, so I have given you the lot of hints. Please try to solve this question. What is the problem that you are facing? Because you are taking so much of time, that is that this time is very unusual. You don't take so this much of time. Okay, just see from here, you will get the value of r as 0.4888. Okay, this is the value of chip thickness ratio that you are getting, and the chip thickness ratio is nothing but t by tc. Okay, so 0.4888, this is equal to T by Tc, and the value of axial feed rate is given as 0.25 mm per revolution. So from here, T is equal to F is equal to 0.25 mm. Okay, 0.25 mm, because this is a orthogonal machining process, right? So this is going to be your 0.25 Tc, and from here you will get the value of Tc as 0.51138 mm. Clear? Till now everything is clear to you? Till now everything is clear to you or not? You have the problem. This is the step 1. This is the step 1. Firstly, you find the tan phi. Tan phi is equal to r cos alpha by 1 minus r sin alpha. From here you find the value of r. Okay, once you find the value of r, from here you use this equation, r is equal to t by tc, and then you get the value of chip thickness. Okay, so यहाँ तक कोई तकलीफ, कोई प्रॉब्लम, कोई दिक्कत, कोई गिला, कोई शिकवा, कुछ भी, कोई भी दिक्कत किसी भी तरीके की? डू लेट मी नो. Okay, so I assume that everything is clear to you. Kindly solve this question. Kindly solve this question. गेट 2003, गेट 2003 की ये क्वेश्चन है. गेट 2003 की ये क्वेश्चन है. Kindly solve this question. Please try to solve this question. Previous year gate 2003. Okay, let me just explain this thing. Option D. Okay, yes, Indrajit, its answer is option D. Correct. Correct. I have received the answer from Mr. Indrajit, and yes, Indrajit, option is D. Correct. See, in this question, a cylinder is turned on a lathe with orthogonal machining principle, right? So there is an orthogonal machining principle is there. Fine. Spindle rotates. Spindle rotates at 200 rpm. The axial feed rate is 0.25 mm per revolution. Depth of cut is 0.4 mm. Rake angle is 10 degree. Rake angle is 10 degree. In analysis, it is found that shear angle is this. So shear angle, value of shear angle is given as this. In the above problem, the coefficient of friction at the tool chip interface obtained using Ernest and Merchant theory. So in this question, it has been explicitly mentioned to use this theory. To use this theory. In question, it has been mentioned that please use this theory, Merchant theory, to solve the problem. So what you need to do, you need to first find the rake angle. So the rake angle is 10 degree. Clear? Shear angle is your 27.75 degree. I have told you, whenever in question it has been explicitly mentioned to use the earnest and merchant theory, you feel free to apply this equation. Phi is equal to pi by 4 plus alpha by 2 minus of beta by 2. Clear? Feel free to use this equation. Always use this equation whenever in the question merchant theory is mentioned, and if it is not mentioned, do not use this equation. So phi is going to be your 27.75, this is going to your 45 degree, plus of alpha by 2, that is 10 by 2, and minus of beta by 2. You have to find the beta. So from here, beta value is going to be around 44.5 degree. Okay, and in this question, coefficient of friction at tool chip interface, so that is nothing but mu is equal to tan beta. So mu is equal to tan of 44.5 degree, and this would be 0.98 approximately. Clear? Clear? So if this is clear to you, kindly solve this question. Kindly solve this question. Try to solve this question. I'm giving you 2 minutes time, and then I'll explain the question. This GATE 2019 problem is there. Please try to solve this question. Minus 5 degree is there. Okay, rake angle. See, there is a one important thing in this question, that since it is a orthogonal machining and you do not know the width value, right? So you do not know the width value, so you can assume b is equal to 1 mm, right? Alpha is equal to minus 5 degree. Feed, so feed is equal to t, uncut chip thickness, this is equal to 0.2 mm per revolution. Now you know these data. Now please try to solve this question. Now please try to solve this question. First step, see, step 1. Step 1. What should be your step 1? Step 1 should be, step 1 should be to find the Fs, shear force. How you can find the shear force? And step 2. Step 2 is should be your Step should 2 should be your this. Find the feed force. Okay, find the feed force. That is the thrust force. In this question, feed force is being asked, and I have already explained you that thrust force is equal to feed force by sine lambda. And in this question is orthogonal cutting, so thrust force is going to be equal to feed force. Okay, so you just need to calculate the thrust force. Asis has given 102. Okay, please check your answer, Asis. If you have any doubt, then please ask with me. Let me check the comment box. Please try to solve this question. I have already explained you the steps. What should be the steps? See, see here. So what do you need to do since it is orthogonal turning? So Fs will be is equal to tau into bt by sine of phi. You know this equation? Shear stress relation between shear stress and shear force. So now Fs is going to be equal to tau. So what is the your tau in this equation? In this question, the shear strength is given as 220 megapascal. So 220 Newton millimeter square into B. B should be 1 mm. T is 0.2 mm by sine of phi. What should be your phi? So how you can find the value of phi? This is alpha is given as minus 5 degree. So you just find the value of phi. What should be the value of phi? See, in this equation, the value of phi is given. Shear angle is 25.4. So just plug in the value 25.4 and try to solve the equation. So it will come around 102.57. Okay, so Asis, you were talking about the shear force. The shear force you were talking about the shear force. So shear force comes to be this 102.57. Now what you need to find? So what you need to find, you know that Ft is equal to feed force. So how you can find the value of Ft? So Ft would be, now I have got the answer from Shivam as 460. Okay, 460. Yes, it is approximately same. Shivam, correct. Mukta told 25. Yes, I have overlooked that part since phi value is given 102.58. Yes, Indrajit, the value of shear force should be 102.58. That's what I have calculated. Okay, so now please try to find the value of thrust force. Now please try to find the value of thrust force. Till now everything is okay. Please try to find the value of thrust force. Step 2 is to find the value of thrust force. uh, Fs is 182. How, Kiran? How? Yes, 102. Yes, yes, what I have, this is what I have calculated. Please try to find the feed force. Please try to find the feed force. See, see the step 2. So from the merchant circle, you can say that shear force is equal to r cos of phi plus of beta minus of alpha. Okay, and you know the value of phi, you know the angle of friction, angle beta, you know the value of alpha. So you just plug in these values, that Fs is your 102.57. This is equal to r cos of phi, that is 25.4, plus of beta is 49.2, so 49.2, and minus of alpha. So minus alpha is already negative, so it is positive. And when you will calculate, you will get the value of r. So r value you will get, that is around 568.25 Newton. Okay, so this is the value of r you have got. So next step is that ft is equal to r sine of beta minus of alpha. So from this equation, ft is going to be equal to r is 568.25 sine of beta. What is beta? Beta is 49.2. 49.2 minus alpha. Alpha is given as minus 5, so minus minus positive would be there, and from here ft is going to be around 460.88. It is clear to you or not? Till now it is clear to you or not? So in step 1, this is the formula. Okay, and by using the merchant circle, this is the formula that we have seen earlier also, and again this is another. When you will draw the merchant circle, these everything will be clear. Till now, do you have any problem to understand this question? Always keep this in mind also, the thrust force and feed force. What is the relation? Okay, because this relation is we have we are continuously seeing this relation in every questions. Okay, in this question also we have seen, right? In this question, see. So just try to remember these things. Okay, so I have got a lot of reply that everything is clear. So please try to solve this question. Previous year GATE 2008. Please try to solve this question. Okay, so in this, shear plane angle and shear force is given. Just ignore this. Just ignore this. Try to find the answer. Try to find this the answer of this question, and then I'll explain you if you cannot solve the question. Syam has given option C. Okay. No, Syam, could you please check your answer? Syam and Mukta, can you please check your answers whether you have committed any calculation mistake? Please check your answers. I'm waiting for 1 more minute and then I will try to solve it. Yes, Asis, answer is D. Correct answer is D. Shear plane is 28. Yes, shear plane is 28, but that does not mean that option C would be the answer. Right, Mukta? D, D may be the answer also. Okay. See, rake angle is given as 7 degree. Alpha is given as 7 degree. Fine. Chip thickness ratio is given as 0.5. Chip thickness ratio is given as 0. Now you apply this equation, tan phi is equal to r cos alpha, and when you will apply this equation you will get the value of phi. So the value of phi is around 28 degree. So it simply means that if it is 28 degree, then this option cannot be the answer and this cannot be the answer. So only C and D can be the answer. Next is what? Shear force. How you can find the shear force? How you can find the value of shear force? Yes, Syam, Shivam, Indrajit, everybody. Option D is correct. Option D is correct. How you can find the shear force? So see, shear force is nothing but shear stress into B into T by, we have seen this equation a lot of time, right? Now see, tau. What is the tau value that is given? That is the shear strength is 250 megapascals. 250 megapascal. What is B? What is B? In this case, see, feed is given as 0.2 mm per revolution. Depth of cut is given as 3 mm, and cutting velocity is given as this. See, depth of cut is given as 3 mm. So depth of cut can be written as B is 3 mm, and feed is given as, feed can be written as uncut chip thickness is equal to point. These two things you have to see for orthogonal machining. Just like the earlier question, in this depth of cut was given, we have assumed B as 1 mm, feed, so F is equal to T. Why? Because this is a orthogonal cutting operation. Orthogonal cutting operation. So similarly, when you will plug in these values, B as a 3 mm and T would be as 0.2 mm divided by sine of phi, sine of 28 degree, and when you will solve these things you will get the value as 320 Newton. Okay, so D will be correct. Clear? सभी को ये सारे चीज समझ में आ रहा है कि नहीं आ रहा है? बता दे मुझे. और आपको अब at this time at this moment, I think you have solved, if I'm not wrong, minimum you have solved something around like 80 to 90 questions of machining, right? 80 to 90 questions you have solved with me of machining. So I think at this moment, are you gaining the confidence or not, that how I can tackle the questions of machining, how I should understand what should be the language of the questions, where I am committing the mistake, and how should I improve my mistakes? Are you getting to understand these things or not? आपको ये सारा चीज समझ में आ रहा है कि नहीं, कि मेरा गलती कहाँ हो रहा है, मेरा गलती कहाँ हो रहा है, गलती को मैं कैसे सुधार सकता हूँ, उसको कैसे मैं देख सकता हूँ, क्वेश्चंस को पढ़ना कितना इंपॉर्टेंट है. नाउ यू कैन अंडरस्टैंड द रीजन. It is very much important to read the question. If you can read the question properly, you can solve the question very easily. You can solve the question very easily, right? Okay, so now try to solve this question. Try to solve this question. Same question is there, but in this question, cutting and thrust force is being asked. Cutting and thrust force is being asked. So you can use the previous data, right? So what are the previous data that you have got? That this is the previous data that you have got, 28 and 320 Newton. So I'm just writing that phi is equal to 28 degree, and shear force is your, what you have got as 320 Newton. So you can use these two data and try to solve the cutting and the thrust force. Asis has told 9 out of 10. Yes, yes. That's why I have also made a video, strategic video, what should be your strategy for your 4 months gate preparation. In that I have told you to make a galti wali copy. I have told you to make the galti wali copy. Why I have told you? Because this copy, in this copy, write the mistakes that you are committing, write the mistakes, whatever you mistakes you are committing to solve the problem. And when you will just turn the pages of this copy, then you will understand, oh, my mistake is the calculation, oh, my mistake is the that I cannot remember the formula, or it was 1 by 2, I have mistaken written as 2. So these mistakes would, make you cautious that, sir, these are your area of mistake, please try to improve it, and hence you will be able to improve this mistakes and everything. And a time will come, believe me, a time will come when you will solve this question without even touching the pen, without even touching the pen, I bet you. But for that you need a lot of practices and lot of concentrations. Okay, so for those who are making the mistakes, please try these things, and definitely you will be able to solve the questions. Okay, please try to solve this question. How many of you are studying in BTech and how many of you are pass out? Try to solve this question. For your reference, I am just making the merchant circle. Okay. So those who are pass out, you need to work a lot of right? You need to work a lot in your preparation, right? और जो सेकेंड और थर्ड ईयर और फोर्थ ईयर में है उनको तो और भी मेहनत करना है, राइट? So they have to give the uh, BTech examination as well as they have to prepare for GATE. So in both the cases, you have to work very hard to crack the GATE. Believe me, cracking GATE is very easy, but the problem is that you have to work a lot. बहुत मेहनत करनी होगी सर. शिवम जी के द्वारा मुझे आंसर मिली है बी. Yes, Shivam ji, answer is B. Correct. Correct. Answer is B. Okay. Now I have drawn the merchant circle in my right side. तो आपको अब यहाँ से क्लियर हो रहा होगा कौन सा एंगल क्या है और कैसे आप उसका रिलेशंस निकाल सकते हैं. No Asis, this is not, option is not B, option is D. See, in this question, what is given? Phi is given, rake angle is given, that is 7 degree. Clear? So you know the alpha is equal to 7 degree, and you know the phi. Now in this question it is mentioned, what is mentioned, sir? Sir, it is mentioned apply merchant's theory, of analysis, right? So how you can apply the merchant theory of analysis? Whenever in question it is mentioned that apply merchant's theory of analysis, it simply means, sir, use the equation. What equation, sir? Angle wala equation, sir. What is the angle wala equation? Angle wala equation says that phi is equal to pi by 4 plus of alpha by 2 minus of beta by 2. Now from here you can find the value of beta. So beta is going to be equal to 41 degree. Beta is going to be equal to 41 degree. Clear? Let me calculate it. Beta value is 41 degree or not? So beta is 41 degree. So now from here what you need to find? You need to find the cutting and the thrust forces. Now see, you know the shear forces. How you can find the cutting force? Right? So see, you also have calculated the value of R. In previous question you have calculated the value of R. Okay, sorry. So from this equation you need to calculate the value of R. I thought it is linked question. Okay. So how you can calculate the value of R? So you can calculate the value as this. Using the merchant circle, Fs can be written as R cos of phi plus of beta minus of alpha, where this is the Fs. So just plug in the values. 320 is equal to R cos of phi. What is phi? Phi is your 28. 28 plus beta is your 41 minus of alpha. Alpha is given as 7. And from here you will get the value of R as 681.62 Newton. Clear? Clear? So you will get the value of R as 681.62 Newton. Now see, you need to find the cutting and thrust force. How you can find the cutting and thrust force? With the help of angles, right? You know the beta, alpha, you know the R. Now please tell me. See, from the merchant circle, what we can see, Fc is equal to, see in this merchant circle, Fc is equal to R cos of beta minus of alpha. Fc is equal to r cos of beta minus of alpha. So we can write here Fc is equal to r cos of beta minus of alpha. So from here Fc will be 681.62 cos of beta is 41 minus of alpha is 7. So your Fc value is going to be equal to, find the value of Fc from this equation, and similarly Ft is going to be equal to r. See, this is cos, so that is going to be sine. Okay, sine of beta minus of alpha. Same thing is there. You have to plug in the values of r, 681.62, sine of beta. What is the beta? 41. What is the value of alpha? Alpha value. Now you can find the value of Ft. How you are getting the value, Asis? Let me calculate it. Asis. Just give me some time. And you people, please you also calculate it. Okay, I'm checking the answers once again. Fc value that I am getting is 565.088 Newton. Okay, and Ft value that I am getting is it is 381.157. Okay, so it is option B. Yes, it is option B. 565 and 381. It is option B. So what I have told option D is the correct. No, option B is correct. Option B is correct. This is the correct. This is correct. Do you have any doubt till now? Do you have any doubt? मैं कुछ क्या गलत बोल दिया क्या आप लोगों को? Let me know. Okay. No. Option B is going to be correct. Option B is correct. Option B is correct. Till now, do you have any problem? कुछ और क्वेश्चन सॉल्व कर लेते हैं, फिर मैं फिनिश कर दूंगा ये क्लास को. ठीक है, कुछ और 2-4 क्वेश्चन सॉल्व करते हैं, क्लास को फिनिश करते हैं, क्योंकि कल से जो है ना, मैं कल से आप लोगों को टूल के बारे में पढ़ाऊंगा. From tomorrow onwards, I will be starting a new topic, that is of tool wear, right? And everything is there. And within 2 classes, I will take more. 2 classes are enough to complete this metal cutting. Okay, this metal cutting will be completed. Now please try to solve this question. Please try to solve this question. Please try to solve this question. Those who are in BTech, 4th year, 3rd year, please share this lecture to your friends, to your classmates, and prepare in groups, right? Prepare in groups. I'll tell, prepare in group study करें आप लोग. Please make a fine group of like 5 to 6 people or 10 people, whatever you want. Make the group and study everything and discuss in that group, solve in that group, try to make a competition in that group. And if you will do this, you will be getting a lot of good score, very good score you are getting. So those who are in btech third and second year and fourth year, share my lectures to your peers, share my lectures to your friends, study in a group. Group study is very much important. That's what I can say. Group study is very very much important. Try to make a group of 5 to 6 peoples and study in groups. This is going to help a lot. This is going to make help you a lot. Kiran has told to start forming after machining. Kiran, see, after machining, welding is very much important. Okay, and welding is very small. I think I'll take um, 2 or 3 classes. See, Kiran and everybody, please see. जितना टाइम मुझे ये मशीनिंग को खत्म करने में लग रहा है ना, उतना टाइम नहीं लगेगा और भी कोई भी सब्जेक्ट को कंप्लीट करने में. बिलीव मी, welding, forming, everything will require like 3 to 4 classes. 3 to 4 classes is more than enough. But this machining is humongous. Machining chapter is humongous, very big, and your concept should be clear in this. That is why I have dedicated a lot of time in that. Rest every chapters, be it forming, welding, casting. I don't think that that will require more than four classes. More than 4 classes, that will enough. That is enough for that. So I'll try to do forming, but building is most important. I'll let you know. I'll let you know everyone that what is the next subject that I'm going to do. Next topic, what I'm going to teach you. Please try to solve this question, everyone. चलिए एक काम करिए आप, इस क्वेश्चन को जो है ना, टेक द स्क्रीनशॉट एंड ट्राई टू डू इन होम. दिस इज द practical. Yes, Kiran, मटेरियल साइंस भी मैं पढ़ाऊंगा. आई टीच मटेरियल साइंस. सी, फ्रॉम मैकेनिकल पॉइंट ऑफ व्यू, from mechanical point of view, if you will see from mechanical point of view, material science constitutes of around 1 to 2 marks, right? So there are some selected topics only in this material science that you need to study. Rest is very easy. Material science will require like 2 to 3 class more. That is enough. 2 to 3 classes enough for material science. Okay, and you are good to go to solve any previous year question. You are good to go to solve any GATE questions. You are good to go. मैं आपको ऐसा पढ़ा दूंगा ना सर कि आप यहाँ से पढ़ के जाइए और क्वेश्चन लगाइए. क्वेश्चन आपसे बनेगा, आपसे क्वेश्चन रुकेगा नहीं. शिवम जी का आंसर आ गया है सी. लेट मी चेक शिवम. यस शिवम, इट्स ऑप्शन इज सी. सो आई जस्ट टेल यू दैट दिस इज अ प्रैक्टिस क्वेश्चन. टेक दिस एज अ प्रैक्टिस क्वेश्चन and try to solve. So Shivam has given the correct answer. अब थोड़ा सा हल्का फुल्का छोटा छोटा क्वेश्चंस देख लेते हैं. ईएससी का प्रॉब्लम है ये 2004 का. काइंडली सॉल्व दिस क्वेश्चन. गिरीश, आई थिंक मोस्टली अभी से लेकर के आप 1 मंथ ले लें और 1 मंथ में आपका सिलेबस पूरी तरह से कंप्लीट हो जाएगा. 1 मंथ से थोड़ा कम ही लगेगा क्योंकि मशीनिंग इज द मोस्ट इंपॉर्टेंट पार्ट एंड दैट वी आर गोइंग टू कंप्लीट इट. Okay, and once the machining is completed, I think more 20 or 25 days is more than enough to complete whole manufacturing. And you know how I teaches the manufacturing. I give you the concept, I make you accustomed with the things, and after that I make you to solve the previous year questions. So this is how I teach you, and this requires a lot of time. But believe me, when you will study this whole manufacturing, you will be good to go to solve any questions. आपको इतना confidence आ जाएगा सर, आप सब कुछ बना देंगे. And that is the my goal, that you should get the confidence to solve a question, है ना? चलिए आंसर आ गया मुझे बी ऑप्शन आ चुका है. यस, ऑप्शन बी इज करेक्ट. ऑप्शन बी इज करेक्ट. क्या बोल रहा है सर? मीडियम कार्बन स्टील वर्कपीस इज टर्न्ड ऑन अ लेंथ ऑफ 50 मीटर पर मिनट. right? So 50 meter per minute is the velocity, 50 meter per minute. So cutting speed, uh, 0.8 mm per revolution is feed, right? So feed is given as 0.8 mm per revolution, correct? Now 1.5 mm of depth of cut. So depth of cut is given as 1.5 mm. What is the rate of material removal? What is the rate of material? What is the rate of material removal, sir? What is MRR? I have told you MRR is DFV. Okay, firstly, see here. So MRR is DFV. I'll come to you, Grace. I will come to you. MRR is DFV. What is D? D is depth of cut. That is 1.5 mm. What is feed? That is a 0.8 mm per revolution. And what is V? V is 50 meter per minute. Okay. So this is in mm. Better to convert this in mm. That is 10 to the power of 3 mm per minute, right? So when you will calculate this, you will get the value of MRR as 6 cube per. Clear? For those who haven't solved it, this is the thing. The relation is this: MRR is equal to EF. MRR is equal to DF. How Girish is getting 0.8? यहाँ तक आपको समझ में आ गया? No problem is there. I think यहाँ तक आपको कोई problem नहीं होगा. Now please try to solve this question. Please try to solve this question. I'll make a production group. Assess. I'll make it. Give me some time. This is depth of cut given, right? This is depth of cut. Okay. So आपका ये कट गया होगा. No problem is there. This is depth of cut. 4 mm is given as depth of cut. Solve this question. Option D. Yes, option D is correct. I'm giving you 1 minute time and then I'll solve it. I'm getting option D from a lot of reply. Okay. See, in this question, a steel bar of 200 mm in diameter. A steel bar of 200 mm in diameter is given. So, which is turned at a speed of 0.25 mm per revolution. So, in this question, again, speed is given as 0.25 mm per revolution with a depth of cut as 4 mm. So depth of cut is given as 4 mm. Next is the rotational speed of workpiece is 160 rpm. So rotational speed is going to be equal to 160. The material removal rate in mm cube per second is what? Sir, what is material removal rate? Sir, material removal rate is area of cut into cutting velocity. This is nothing equal to, sir, this is equal to dfv, right? So mrr is going to be equal to your d, that is depth of cut is 4 mm, feed is your 0.25 mm per revolution into, now see velocity. How you can find the velocity? So velocity is going to be equal to, see, pi d n by 60. Okay, pi dn by 60, where d is the 200 mm in diameter. So pi d is your 200 mm, n is your 160 rpm, revolution per minute. This is going to be your 60. Clear? So from here, see, this revolution get cancelled. This is your mm, this is your mm, this is your mm, so mm cube, and this is your minute. They're asking in second, they're asking in second. So from here you will get answer in, this is in second. Okay, so mrr is going to be equal to, you just calculate, and that is 1675.5 mm cube per, you will get the value as. Clear? Clear to everyone? Now please solve this question. Now please solve this question. 1000 when we are dividing by 1000. See, see here, Assis. In question, it has been told to give in mm cube per second, right? Mm cube per second. So try to find the answer in this unit. So how you can find the answer in this unit? Try to write the units in this form. Okay, try to write the units with the, when you are calculating that mm per revolution, mm and revolution per second. So what will happen, then the same time you will be understanding that, okay, so this is how I have to convert. If this is in meter, I have to convert in millimeter, then I have to multiply by 1000 and divide by so this is how you have to think in your mind, कि आपको कब क्या कैसे लगाना है, यूनिट्स को हमेशा लिखते रहें. When you will write the units, then you will be able to solve the questions. ठीक है? Kindly solve this question. See, a 125 mm long, 10 mm diameter stainless steel rod is being turned to a 9 mm diameter, right? So earlier it was a 10 mm diameter steel rod was there. It has been turned to 9 mm diameter. So depth of cut is given as 0.5 mm of depth of cut. So earlier there was, So this is your 10 mm and this is your 9 mm. Clear? So depth of cut is given as 0.5 mm. Spindle rotates at 360 rpm with the tool transversing at an axial speed of 175 mm per minute. Metal removal rate is nearly what? So I got an answer from, okay, so option D. No, option D is wrong. Shivam, kindly check your answer. Okay, so see, I just leave this for your practice to this question, and I will, in the upcoming class, I will explain the concept to find the material removal rate in case of turning operation, in case of drilling operation, in case of shaping operation, in case of milling operation. Okay, these things I'm going to tell you in the upcoming classes. So how you can find the MRR and what are the things. For now, time being, practice this question. Is it A, sir? Okay. No, no, sir. This is not A. I'll explain the concepts, these things. Okay. Do not worry. Please see this question. Please see this question. In this question, an orthogonal machining of a job at a cutting speed of 90 meter per minute with the tool rake 10 degree. Cutting force and thrust forces are given as 750 Newton, 390 Newton. Assume a shear angle to be 35 degree. The power expended for the shearing along the shear plane is what? Yes, Shivam, the answer was C. Yes, you have given the correct answer now. शिवम जी जो हैं वो बैक टू बैक दोनों प्रैक्टिस क्वेश्चंस का आंसर तुरंत तुरंत बता दिए हैं. दैट्स वेरी गुड शिवम. योर प्रिपरेशन इज वेरी गुड. योर प्रिपरेशन इज वेरी गुड. See, this is a very easy question. कोई भी सॉल्व कर सकता है, but still I haven't received any answer. Tell me the answer. एनर्जी कम हो गया क्या आप लोगों का? If that is the case, then I will finish it. See, this is a very routine question. You have to find the power. Tell me the power. The power expended for shearing along the shear plane, right? So you have to find the shearing power. Tell me the value of power. 586. No. Okay, so आप लोगों को काफी प्रॉब्लम हो रहा है, आई थिंक. So I will just try to wrap up this problem. अगर आपको कोई प्रॉब्लम है, कोई डाउट्स है, तो आप मुझसे पूछ सकते हैं। अदरवाइज आई एम गोइंग टू एंड द सेशन बिकॉज आप लोग पार्टिसिपेशन नहीं कर रहे हैं, है ना। एनर्जी की कमी आपको महसूस हो रही है क्या? टेक दिस क्वेश्चन एज प्रैक्टिस, ओके। टेक दिस क्वेश्चन ऑल्सो एज प्रैक्टिस। टेक दिस क्वेश्चन ऑल्सो एज प्रैक्टिस। ठीक है, मैं आपको काफी ज्यादा क्वेश्चंस करवाने वाला था, बट अब आप इन सारे क्वेश्चंस को आप प्रैक्टिस में कर लें। ठीक है, इन सारे क्वेश्चंस का आप स्क्रीनशॉट खींच लें and try to solve these questions in your home. And if you face the problem, then I will explain you in the upcoming videos. Okay, these all questions are for your practice. This is also for your practice. Till now, if you have any doubt, till now, if you have any doubt to this entire session, you can ask with me. All the questions are for your practice. Take the screenshot. ठीक है, कोई प्रॉब्लम है तो आप मुझे बता दें, अदरवाइज आई एम गोइंग टू एंड द सेशन। क्या कर दूं, सारा क्वेश्चंस अभी कर दूं? टेल मी। सी अप्रॉक्स 90 to 94% of questions, previous year questions has been covered in this lectures। मैं आपको भी जितना भी वीडियो लेक्चर्स बना के दिया हूं उसमें 90 to 94% आपका प्रीवियस ईयर क्वेश्चंस ऑलरेडी कवर्ड है। सो जस्ट यू शुड नॉट फील कि आपको प्रीवियस ईयर आप बना नहीं रहे हैं, आप प्रीवियस ईयर ऑलरेडी बहुत बना चुके हैं, आपको पता नहीं चल रहा है। ठीक है, सो that's okay, no problem. That's why I have given you to practice these all questions in your home, and in the next video please let me know that if you have the problems, then I will solve each and every problems, okay। मैं सब करूंगा, मैं कहीं भाग नहीं रहा हूं, ठीक है। So these are the things, if you have any doubt then please let me know। कोई कंफ्यूजन, कोई डाउट्स अगर है तो आप मुझसे पूछ सकते हैं। एंड इफ यू आर प्लानिंग फॉर द प्लस सब्सक्रिप्शन, देन यू कैन यूज द सर्वीके कोड, you will get the 10% off in this plus subscription. As well as tomorrow I am going to take the strength of material at the same routine time, 11 a.m. 2 hours. Fine. Manufacturing is what, 8:45 p.m. 2 hours approximately, right? So this is the thing that we are going to do. If you have any doubt, then please ask with me. And if you are planning for a plus subscription, you can use my code SIRVK. And you will get a 10% off. कोई कलीग्स, कोई पीयर्स, कोई भी कुछ भी हो, कहीं भी हो, अगर उनको प्लस सब्सक्रिप्शन लेना है तो आप उनको मेरे कोड को शेयर कर सकते हैं, सर्वीके। सो आई अज्यूम यू डोंट हैव एनी डाउट। तो थैंक यू सो मच फॉर योर एक्टिव पार्टिसिपेशन। मैं 1 मिनट और रुक रहा हूँ, अगर आपको कोई डाउट है तो मैं आपका डाउट्स ले लूंगा। आई एम गिविंग यू 1 मिनट टाइम। इफ यू हैव एनी डाउट then I'll explain your doubts, otherwise I'm going to end the session। अच्छा, आप लोग बताएं, मैं तो आप लोगों को इतना सारा प्रीवियस ईयर क्वेश्चंस करवा रहा हूं, अब आपसे प्रीवियस ईयर बन रहा है कि नहीं? When you are opening the book of a previous year, or when you are downloading the questions, now you can solve the questions or not. जब आप मैन्युफैक्चरिंग जब आप स्टार्ट किए थे तब आपका क्या स्टेटस था और अभी आपका क्या स्टेटस है? आई वांट टू नो द स्टेटस. व्हाट इज योर स्टेटस? हाउ मच you have been benefited from my class? Okay, and if you have any doubt, please ask with me. 1 से 2 मिनट तो हैं ही, मैं आपका डाउट्स ले लूंगा. गुड. मुक्ता जी का कहना है यस सर बन रहा है. यस, बनेगा ही बनेगा, वो बनेगा ही बनेगा. आशीष जी बोल रहे हैं यस सर, नाउ आई एम गेटिंग लॉट ऑफ करेक्ट आंसर. यस, सी अर्लियर अगर आपसे मिस्टेक हो रहा था ना सर, अगर आप 10 क्वेश्चन उठा रहे थे और आपसे अगर 2 या 3 क्वेश्चन बन रहा था, अभी अगर आप 10 क्वेश्चन उठाएंगे सर, आपसे 8 या 9 क्वेश्चन बन जाएगा सर. दिस इज द थिंग दैट आई वॉन्ट टू टेल यू. यस. हाँ, प्रैक्टिस क्वेश्चन तो डेली चाहिए ही ना. मैं प्रैक्टिस तो करवा ही रहा हूँ, आप मेरे साथ ही प्रैक्टिस करें. ठीक है. Practice with me. If you will practice alone, you will take a lot of time, and there is a chances that आपका बहुत टाइम भी किल हो, और टाइम भी इतना नहीं है ना, तो आप मेरे साथ अगर प्रैक्टिस करते हैं तो क्या होता है, मैं आपको एफिशिएंट वे में आपको बता भी देता हूँ, आपका कॉन्सेप्ट भी क्लियर हो जाता है और सारा का सारा पोर्शंस भी कवर हो जाता है. एंड दिस इज व्हाट इज द लॉजिक बिहाइंड क्रिएटिंग दिस कंटेंट फॉर you guys. Good. It's really happy for me to get this feedback, Mukta. Yeah. Okay. So thank you so much. I also enjoy while taking the classes of you people. आप लोग के कारण मैं क्लास जब लेता हूँ तो मुझे भी बहुत मज़ा आता है. थैंक यू सो मच फॉर योर एक्टिव पार्टिसिपेशन, एंड गुड नाइट.